We're going to cover passage 5, questions 28 to 33. This is a data passage, and I know this data because we only see information. It doesn't say study 1 or study 2. So as a brief introduction, which I like to skim, you're going to look at the variables, and then you're going to go to the questions. You want to do the questions relatively quickly, I think 10 to 20 seconds into the questions. Number 28, what is the approximate maximum coefficient shown in figure 1 for a 200 hertz sound wave at 10% relative humidity? And at approximately what temperature does that maximum occur? So we're looking at figure 1, and we're looking at 200 hertz, which is this line. And the maximum is right here, which is at 3, so we know it's not H or J. And that temperature maximum looks like it comes right around here somewhere. So here. And that's -5. So our answer has to be F. Number 29, based on figure 2, the attenuation coefficient for a 1000 hertz sound wave in air at 20 degrees Celsius reaches a minimum value at a relative humidity closest to which of the following? So 1000 is the straight line, so this line. And it looks like the minimum is right around, I don't know, here somewhere. And so that would be 45, so B. You can see it goes up slightly over here. Definitely is bigger over here. So somewhere around here is the minimum. So it has to be B, 45. Question 30. For the range of temperatures and the range of relative humidities shown in figures 1 and 2, is the coefficient for 200 hertz sound wave more strongly affected by changes in temperature or humidity? So the 200 hertz sound wave is this one. And that's this one right here. So that's what we're looking at. We want to see, is it more affected by temperature or humidity? And we can see there's not a whole lot of change in either of them, but the temperature goes up to 3 and down to almost 0, where the humidity goes between maybe 1 and 2. So I would say it has to be temperature. So we're going to eliminate humidity. We just got to see which one is correct. But the maximum variation is about 0.5. Seems bigger than 0.5. The maximum variation is about 2.5. Yeah, that's the correct. It goes from almost 0 to 3, so it's about 2.5. So our answer has to be G. Question 31. Consider a 1000 hertz sound wave at 10% relative humidity. How many temperatures shown in figure 1 does the coefficient have a value of 18? So the 1000 hertz is the straight line, this one. And 18 is right here. And so it has 1, 2, 3, 4 where the lines cross. So 4 different times that it has a temperature, a value of 18 for the different temperatures. So C. I don't think I explained that well. 1, 2, 3, 4. Each of those times that 18 crosses the temperature line, it has a value. So C. Question 32 is a suppose question. So anytime we have suppose, if, or why questions, that means you're going to have to think about it. It's going to give you some sort of different data. So in this one, suppose 2 waves, 150 hertz sound wave. So there's not 150 here. So the 150 is going to be below the 200. That's the extra information. And an 1100 hertz sound wave. So 1100 is going to be greater than that one. Are simultaneously emitted from a speaker into air at 20 degrees and 45% humidity. Based on figure 2, as the wave travels away from the speaker, the intensity level of which wave will more likely decrease at a greater rate. So it's a little bit of knowledge. So as the wave goes further and further away, which one will decrease at a greater rate? So if we start with, so we're looking at 150, which is going to be below this one, right? So below this one, so below 200. And we're looking at 1100, we'll do a different color, 1100, which is above this one. So as we go away, I'm going to use logic and say the decrease at a greater rate has to be the bigger wave. We can actually see it decreasing here. So the greater wave will decrease. Now let's look at the answers. The 150 hertz wave, because the value of the coefficient is lesser for the 150 wave than for the 1100 hertz wave. That is true, but it doesn't. Let's probably go the opposite of that. Let's see if this one's it. 1100 wave, because the value of coefficient is greater for the 1100 wave than the 150 hertz wave. That's got to be the answer. So it's got to be J, because it has further to, it starts higher, so it can decrease at a greater rate. Now, even if that doesn't make total sense, you could eliminate G and H because they just speak things that aren't true. The 150 hertz wave, because the value of theta is greater. No, the value of theta that's not theta, the coefficient, is greater for the 1100, not the 150. So 1100 wave, because it's lesser, that's not true. So at worst case scenario, you get a 50-50 shot between F and J, just knowing which one speaks the truth. And then you have to use a little bit of your logic, because it is a supposed question. The graph below shows for sound waves with 3 different frequencies how the coefficient varies with relative humidity and air at a particular temperature. Okay. Based on figure 1, the particular air temperature is most likely which of the following. So we have to match this chart with this chart, the temperature. Easiest thing to do is just look at the, let's just process and eliminate, negative 20. So at negative 20, negative 20 isn't even shown here, but they would all be right around 2 or 3, and it doesn't look like that's the case, right? So, because it looks like 10's going back up. So I'm going to say negative 20 is definitely out. So about 0 degrees. So it's going to cross right at 15. So I can imagine it's about 15. So that one is about 15. And then let's say about 9. That's about 9. And then 3-ish. So that's 3-ish. So all these are matching up. So since they match to this section here, I'm going to say it's 0 degrees. So B. That's a bit of a tricky question just to figure out where I ought to look on that one. Okay, reach out if you have any questions.